So, hello everyone. My name is Isha Nima, and I love data science. And my love blossomed like 10 months ago with data science. And from then onwards, I am learning it from various resources from the net, and I have been, working on some of the Kaggle data sets to get an idea, get a feel. I've also participated in few of the Kaggle competitions. And yeah, so that is how my journey from 10 months is. I am Scrum Master by profession. And so that's it about me. And regarding today's topic, outlier detection. So this basically have stuck me when I was working in on one of the Kaggle competition database. I think many of you must have heard it. That is New York taxi fare estimation. From there, I was working on the data set and I felt that some of the values, like as long as zero and many of those things, were so incorrect. Previous to that, I have worked on basically much of a very clean data uh, from databases, and basically it was the data I have chosen was mainly to learn the machine learning algorithms and everything, but this was the real data which I worked upon. Apart from that, I have worked on computer vision also. So this was the first time I saw this data, and I didn't know what to do about it, so I just started researching, and this is how my research went by on an outlier detection. I started, and one very unusual thing is you would never find much resources or tutorials. Even the tutorials on Udemy, Udacity will never talk about outlier detection, though it is the primary part of it. So that is why the scarcity of the resources to understand what about this outlier detection. Um, actually, due to this, I went into this field and I started reading more about it. So, for the basics, let me start with what is an outlier. Outlier is basically nothing but an observation that is unlike the other observations, and it somehow doesn't fit in some way. So, like here in the marbles picture, if you will see, so there are four things which you can see, or sorry, three things which you can see. First is these are marbles of green color. Second, there is a red color marble, and third is there are few marbles on the sides because of the light or because of the one shade lower thing, they have a lighter shade of green color. So if I see or analyze this picture, this more often look like an data, which is normal data, which is green in color marbles, and this is an exceptional data. That is my outlier data, which is red in color, and these light balls on the edges looks like a noise, rightly, which are basically nothing but an green marble, but they somehow doesn't fit in this shade, but still they are green marble, so this is noise. So I think they now you have a clear distinction between, or you can clearly distinguish between these two, the outlier and a noise. The next is, let's go dig into our data. Like here, there's a database. So let me tell you about a story about it so that it will help you understand about this data. So there's a Mr. X who was working on a machinery, who changes something into his machinery and note down the heat and vibration produced by the machinery into it. So what he's writing is heat and vibrations. So while he wrote it all down, he handed over the sheet to his assistant for logbook record. So once this assistant started putting that into Excel sheet, he created a scatter plot of it, and then he saw that there's very uh, a very distant point out of these points, which he thinks it's an outlier because all the points are in this range, and only this point which belongs here is a very have a higher or is not very close to these points. Now there can be few reasons to it. When assessment wanted to find out that what could be the reason of it, first he thought that it might be a measurement error or an input error. That okay, this there can be some mistake in while writing this data or while reading this data out. There might be some error, and that is why it's there. There might be some conditions, like the machine was working from so many time for so many times. There was so much experiment done on it, that is why it got heated up. So that can be a reason for an outlier observation, which is not an incorrect observation, but it is true outlier observation. Next is this can be the first step towards some a big discovery. This can be a reason to it that okay, after doing these steps, though I'm not increasing the vibration, my heat can be increased, and yeah, there can be a possibility of a discovery. So now what we have seen is what is an outlier, what is a noise, and what is basically it reasons behind it. Now one thing which comes generally in the mind that okay, why should we bother about it? So there are few reasons that why this can be real pain. First point is that there's a high probability that the outlier will by potentially skew or bias your analysis. Like in here, if you will see, this without outlier, the mean median mode is completely different with outlier with respect to the with outlier readings. Like here, there's just a addition of 300 into it, and here you will see mean, median, and mode, and standard deviation to be completely different from this observation. So this is how these outliers change your data completely, the analysis of your data completely. Next is for a specific algorithm like clustering, it can distort your clusters like anything. And it can also, even the analysis of these outlier can may lead to new formulation, like what we discussed in Mr. X case, that he was reading this 300 reading might be the first step towards his discovery about something. So that is why the outliers are really important. Okay, outlier types. Outlier types basically, till now we read about how the outliers can be helpful or it needs to be taken care of. Now we need to see that how we can classify these outliers. Outliers basically can be classified based on values and environment. When we see that here you will see that outlier can be broken into two by univariate and multivariate. The example here you will see is an univariate example wherein we are just considering the variable x. Suppose this is variable x values, and we are just detecting an outlier by just analyzing this variable. So these are called univariate outliers. Now, the multivariate outliers is basically a combination of unusual score of at least two variables. For example, an HR wants to see the salary of the employees under her or him. He gives a task to his assistant. He, when the assistant brings up the sheet, he clearly sees that there's a 1 year experience guy. He have written as 1000 rupees per hour. For 2 years, it is 2000 rupees per hour. For 3 years, it was 500 rupees per hour. And for 4 years, it was 6,000 rupees per hour. So, for clearly, this third one is an outlier, though it might not be an outlier individually, but yeah, combination of experience and a salary is an outlier. So, that is why it's a multivariate outlier. Next is outlier type based on environment. So basically, I'm sorry. So when we were seeing this case of Mr. X, we saw that there was one point which was distant from all other point, and that is how we knew that this is an outlier. So same case with the point one. Contextual is nothing but a conditional outlier. That means that if herein the contextual outlier will be easier to be found out, or somebody who have a good domain knowledge can work on these contextual outliers really well. So, like if I'm studying temperatures of various part of India, under various in various seasons, and I suddenly see that there's Shimla and the temperature reported is 3 degrees, and I would be like, if I don't know about India, I would say that no, the overall temperature in India is around 20 to 40 degrees. How 3 degrees is possible? But somebody who knows about India would say no, it's a hill station. There's a probability that in winters the temperature would have been recorded, and that is why this is an uh, this is not an outlier. Next is the collective outlier. Collective outlier is nothing but an an outlier basically if seen in collection. So for example, let me explain you this way. So there are few computers who are working on who are connected to a network, and suddenly 5 out of the 7 computers have started the denial of service packages. So if a single computer was doing that, that would be okay. That is sorry, that would be fine. But collectively, if they are doing it like 5 computers, 6 computers are doing that, it's an intrusion detection case, and we need to find out if there's an intrusion in our network. Cool. So herein we understood about how an outlier detection is dissected. Please post your questions up till now in the comment section so that I can answer you. Please, yeah, till here, yeah. So next is my outlier detection method. So we have seen that there are various type of data available. So based on these data, we will see that whether it's a supervised data, a supervised learning outlier detection method will be used, unsupervised or semi-supervised will be used. Just to tell you a brief about what supervised, unsupervised, and semi-supervised is. Supervised is something wherein we know the boundary between these 2 points, and we know that okay, this belongs here and this belongs here. In unsupervised, we don't know the dependent variable in training set as well as in the test set, and semi-supervised, in which we know about a few of the classes. Like in here, you know the class, this sphere or this ball belongs to blue, and this ball belongs to green, but for the rest you don't know about them. So this is a case of semi-supervised. In this algorithm, basically this is a very interesting algorithm in which our machine learning algorithm or our algorithms try to figure out the data, or they predict the data based on the these labeled one, and then get to know that okay how environment sees, and that is why they try to build a boundary around these data. Now let's play with the data. So there's a problem statement. Mr. Sharma wants to join ABC company. He claims he's working from 10 years and his salary is 1 lakh per month. HR want to predict what is the package offered to a person with the skills he possesses. He does some market research and put the finding in an Excel sheet. So here you will see the years of experience and the salary. So first and foremost, to know about this data, we need to put them in a scatter plot. When he puts them in a scatter plot, he finds this as an outlier. And rest, he knows that okay, it mostly is a linear graph in which y equal to mx plus c will work, and he needs to offer him the salary on this scale. For this, he might want to see that why this person or this is an outlier. So he highlights this point, and now to either he can delete it, like what we were talking about it here, that he can just say y equal to mx plus c, ignore this point, and yeah, he's done. Next, what he can do is transform the variables. So for this case, basically when we do a transformation, like there's an example which I should give it to you. Like we are evaluating IQ of 100 people, and we wrote it down. Out of those 100 people, one was Stephen Hawking. Now we have 99 entries which are in a cluster, and Stephen Hawking IQ obviously is very high. So he looks like an outlier, but he's not, and we need to consider that his IQ also in our uh, study. So what we will do is we will take a log of it. So natural log of a value are assigning weights to different observation reduces the variation by the stream values. We can also do imputing, wherein we will use the statistical methods to impute the value, and basically to predict the value and impute it to the data. Now, problem statement of a supervised learning. So this is a basically Kaggle competition. I'm sure everybody must have seen this. And this is an anonymized credit card transaction labeled as fraudulent or genuine. So this is an Excel sheet. I will just open it for you. I think I have it opened it here. Okay. So this is an Excel sheet wherein we have time, we have this principal component, V1 to V28, we have amount, and we have class. In here, if you will read this class has 0 for non-fraudulent transactions and 1 for a fraudulent transaction. Okay. Now let me go to my Python code, wherein I have these import function. Let me just this. I'll just first clean all my variables. Just give me a few minutes. Okay, I will upload my database and data frame. I want to check the distribution of the data, and I will see that these many are non-fraudulent transaction and these is a fraudulent transaction. This is a classic example of my unbalanced data. Okay, for cases like these, uh, we need to see that what we can done best or what can be done, because this kind of situation creates a biased results towards, it will be more biased towards an non-fraudulent transaction rather than a fraud transaction. So let's see how to deal with that. So for this, I will put this into the X and Y thing. I will do a pre-processing. I will define the model here, select it. I will do the split the database, select the train and test data. I'm so sorry, there's an error. Oh, this looks like an error. Okay. Now let's do this. I'm so sorry. Now we will project it. Whoa. Now you will see non-fraudulent transaction is 9476. Non-fraudulent transaction 94,763, and for our Y test, how many were 94936, and we predicted that only 200 incorrectly, and apart from that, all were predicted correctly. Now, if you will see, not fraud but reported as fraud as 9. So they were not fraud but they were reported as fraud as 9. Fraud but not reported as fraud as 78. And frauds is 86. So my concern here is this, that they were actually fraud and my system was not able to identify that these were frauds. And my aim was here not to detect that which one is a non-fraudulent or which one is fraudulent. I mean, which one was not fraudulent. My here aim was to find out the fraud transaction, and we can work upon this and try to minimize this as much as possible. So here our aim is to reduce this fraud but not fraud transaction. So this is one of the way in which I have done it. There can be multiple ways, multiple algorithms you can use to do it. So it's all up to you. Whatever you find, see is fine. You can do that. And yeah, so this is my list. Okay, so now going back to my presentation. This was one of the example of supervised learning. Why supervised? Because we have this Y present in here, and we know that what is the clear distinction between fraudulent and non-fraudulent transaction. Next is problem statement. This is an unsupervised learning case wherein we have an outlier detection algorithm which detects users who are outperforming and or underperforming with respect to the peers. So if you will see, let me just show you the data first. Okay. this is my data, wherein I have something called as complexity scale. This also has been encoded by a company. So that is why we don't know what this complexity scale is. And this is the duration. These are the tasks which were assigned to them, and these are the users which were there. So my here aim is to find out that if the complexity is this much, what ideally the time is taken by all the users against, complexity against the total duration. So this looks more of an, while going through the problem, we need to first understand that we should not just rush towards applying a machine learning concept here. It can be done through simple statistics methods also. Like in here, what I did was I created a data set. I fitted into a regression model, linear regression model, because when you will see here and you try to run scatter plot here, can you see this scatter plot? We'll just put this line. Oh, you understand this? This line is defining my. This line is very well defining my distribution, but there has to be a threshold. If you will see, there has to be a threshold wherein you will say that okay, up till this point it's okay. I mean, it's okay if he doesn't fall into this line. So there has to be an area which is a permissible area or a threshold area which you need to select based on hit on trial or fine tuning your parameters. And apart from that, whatever is outside that area should be an outlier. So I'm doing the similar thing here. I did this. I'm so sorry. This man. Let me just check this data set. I'm going to start from the 0, 1, 2. Oh, my bad. 3. Now what it will do is it will this logic basically gives you the row number wherein the outlier is. So this is just an thing which I did. Apart from this, if you want to display the users who are an outlier, you can put it into again to the data set. Whatever you want to do, you can do using this data set dot iterative rows. And this can be really helpful in putting out that okay, this user is often an outlier. So how to do it? I'll just try doing it now. Let me try it. Outlier 3, 0. Yeah, I think I have to change the whole set. I'm so sorry. Yeah, so you can do it using it. I have to change, I think, the data set which I have fixed it right now. Okay, so this is what the outlier, supervised, unsupervised. I wanted to bring that specific example instead of any complex example just because I wanted to show you that there might be cases when you will feel that this is unsupervised learning and you will feel that, oh, now I cannot handle it. That cannot be a situation which that should not be any scary situation because many of the problems you can just solve by using statistics. So the only big question you should ask yourself at the time of outlier detection is, why do I want to detect the outlier? Do I want to just do outlier detection to clean up, or you want to do an outlier detection to infer something or to find out the outliers as such, like what we did in uh, fraud detection? Oh, sorry. Yeah. So that's it. Thank you so much, guys. Please feel free, as I said, to put your comments in the video section.